Okay, we are on number 3 from the 2023 AP Calculus BC Exam FRQ number 3. A much lower average than the first two problems from this exam. Still a little bit above the global average, which of course is a little bit above the Texas average. Okay, let's take a look. So no calculator. We're on number 3, so no calculator. A bottle of milk is taken out of a refrigerator, placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk. So m is the temperature, and it is increasing because it's in a pan of hot water. Okay, at time t, where m of t is measured in degrees Celsius. T is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm dt is equal to 1/4 of 40 minus m. At time 0, the temperature of the milk is 5 degrees Celsius. They are giving us an initial condition. It can be shown that m is always less than 40 degrees Celsius. Okay, for all values of t. All right, I don't know why they're telling us that, but I have a feeling we're going to need it because that is too random a fact for them to give us without it coming into play sometime. So we will keep that in mind. All right, part A. A slope field for this differential equation is shown. Sketch the solution curve through the point 0,5. So if you are fortunate enough to have one like this is an easy point. It's probably only worth 1 point, but it is, I think, a very easy point. The first thing you do is go to the point 0,5. The point 0,5, and they were so kind, they already marked it for us. Unbelievable. Very kind. Okay. We're going to follow the path given to us and that's it. You're done. You are done. So they will be looking for some things, you guys. Number 1, they need you to start here. They need you to go through the point that they gave you, that they told you to go through. If you go through this point or some other point, you're not going to get credit for this. You have to go through the point that they gave you. Okay? They are looking for this thing to be concave down. They are looking for it to be asymptotic to this horizontal line here. They're looking for it to be asymptotic. They are looking for you to go through the entire graph provided. If you stop here, you will not get credit. Okay? They gave you this graph. You use the full graph. Okay? From far left to far right, you use it. It's an easy point to get, but you have to give them certain things. Okay? All right, part B. Use the line tangent to the graph of m at t equals 0 to approximate m of 2, the temperature of the milk at time 2. Use the line tangent. Well, if they tell me to use the line tangent, I'm going to use the line tangent. I think I'm going to come up here and do this because I don't have a lot of space on this page. So I'm going to come all the way up here and do it way up here. Line tangent. If they tell me to use a line tangent, I'm using the line tangent. And to use a line tangent, I have to write the equation of the line tangent. So for that, I need a point and a slope. Point and slope, right? Point and slope. They gave me the point to use. They said to start at time 0. They said to use time 0, and I know what the point is at time 0, so I am using the point 50. And now for the slope, they gave me a way to find slope. dm dt at the point 50. So I'm putting 0 in for t, 5 in for m, right? There's no t over here. I'm going to put 5 in for m, not the 0. 0 is t. M is 5. So it's going to be 1/4 times 40 minus 5, which will be 35. So that is 35/4. And now for the equation. Y minus the y coordinate of the point is equal to the slope times x minus the x coordinate of the point. Now they wanted us to approximate m of 2. Y is m, so m of 2 is approximately equal to, I'm bringing the 5 over, and I'm replacing x with 2. And I'm done. That is the approximation for the temperature of the milk at time 2 using the line tangent. Part C. Write an expression for the second derivative of m with respect to t in terms of m, and then use the second derivative to determine whether the approximation from part B is an under or an overestimate of the actual value. So, second derivative is going to tell us concavity. If our curve is concave down, a tangent line will lie above and be an overestimate. If the curve is concave up, the tangent line will lie below and be an underestimate. So let's find the second derivative. I'm going to take the first derivative, which they gave me. They gave me the first derivative. And I'm going to take the derivative of both sides with respect to t. And I'm going to get the second derivative. Okay. 1/4 times 40 is 10, but that's just when we take the derivative of a constant, that's going to be a 0. 1/4 times negative m is negative 1/4 m, and the derivative of that is negative 1/4 dm dt, because we're taking the derivative with respect to t. Okay? So that is the second derivative in terms of dm dt. We needed to write it in terms of m only, so our only variable can be an m. So I replace dm dt with the expression for dm dt, 1/4 times 40 minus m. And so I have my expression for the second derivative in terms of m. Okay, now we need to determine, is this positive, negative, whatever? They told us that m is always less than 40. M is always less than 40. And if m is always less than 40, this is positive, so the whole thing is going to be a negative. So I need to say my thought process, say what I'm thinking. Since m is less than 40, the second derivative is always negative, less than 0. Therefore, a tangent line approximation will yield an, concave down, like a frown. Tangent line is over the curve, an overestimate. Okay? Part D. Use separation of variables. Separate and integrate to find an expression for m of t, the particular solution to this differential equation with initial condition m of 0 is 0. All right, I wonder if I can squeeze it in down here. I'm going to try. Okay, so we have dm dt is equal to 1/4 times 40 minus m. to separate, I'm going to divide both sides by 40 minus m. So I'll have 1 over 40 minus m dm, and I'm multiplying both sides by the dt. I still have the 1/4 over there, so 1/4 dt. If you want to, you can make the 4 go over here, but you're going to have to divide by it sometime, so why? Why bring it over and then divide? Why multiply, then divide? Just leave it there. My thought. Okay, now I'm going to integrate both sides. I separated, now I'm integrating. The antiderivative of 1 over 40 minus m is negative ln absolute value 40 minus m. They need to see the antiderivative, so give them the antiderivative. Okay, where did the minus come from? The use of that we just did mentally. Okay, the derivative of the denominator. And this is equal to 1/4 t plus c. Okay, this negative. What do we do with the negative? Does it distribute? No. That's not a log property. No number out in front distributes to the argument of a log. Instead, I'm going to multiply both sides by a -1. And we get negative 1/4 t. And then this, you can write it as a minus c if you want, or it's just a constant, so I'm just going to leave it a plus c. Now I'm going to e to both sides. When I e to both sides, I can write this as 40 minus m is equal to c e to the negative 1/4 t. When you e to both sides, you can lose the absolute values because of how we wrote it over on this side. Okay? Now to find c, I'm using that m of 0 is 5. So I'm putting 5 in for m, 0 in for t. And I get 35 is equal to c e to the 0. So c is 35. Therefore, I go back to my equation that right before I plugged in 0 for t and 5 for m. And I'm going to have 40 minus m is 35 e to the negative 1/4 t. Last step, solve for m. Negative m is negative 40 plus 35 e to the negative 1/4 t. So m is 40 minus 35 e to the negative 1/4 t. Okay, how was this scored? Part A, the slope field, was worth 1 point. Not the slope field, the solution curve. Okay. Part B, 1 point was given for the slope, dm dt, at time 0. dm dt at that time 0, and then 1 point for the approximation. Okay, part C. Part C, 1 point was for the second derivative. 1 point was for the second derivative in terms of m. Okay, and then 1 point for overestimate with reason. And then part D was worth 4 points. 1 point for separation of variables. Always get a point to separate. 1 point was for the antiderivatives. 1 point was for the constant of integration, the c. And uses initial condition to find c. Oops, I didn't know I was off the page over here. And uses the initial condition. And then last point, solves for m. So that's how they scored that one.